Hello. All right, so Miss Bodette here. Okay, so hopefully by now you guys should all have your question of the day done. Reminder, tonight's homework, well, sorry, last class's homework was page 9 through 10, so that should already be done. If you didn't do it, you should feel bad, but you are actually lucky because I am not there to collect it. So that means next class, page 9 through 10 and page 11 through 12 are done. So 9 through 11, all of those pages should be done by next class, which you guys have a while for that, right? Because you have all of fall break. So when we come back from fall break, the Tuesday after fall break, 9 through 11 is due. You also need to work on your Unit 3 review sheet. So the substitute teacher should have passed that out. You should all have a Unit 3 review sheet, and that is due Wednesday, October 20th. So again, page 9 through 12 and Unit 3 review sheet. Okay, so let's go ahead and start by going over the question of the day. So the question of the day involved phosphorus, which is right here on our periodic table. Phosphorus has 15 electrons based on this number 15 right here, right? So phosphorus has 15 electrons. You should have hopefully gotten that part correct. And we will go ahead and draw the Bohr diagram for phosphorus. So the symbol is a P. It's got 15 electrons, so there should be 15 dots. I'll go ahead and start out with this first shell here. We know the first shell holds 2 electrons, so there's my 2 electrons in the first shell. The second shell holds 8, and remember they go alone and then they start pairing up. So they should look like this. There we go. Let's see. So far we have 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we need to get to 15. So we need 5 more. So I'm going to start a third shell. And this one has 5. So 1, 2, 3, 4, 5. So your phosphorus should look something like this. It should have 15 electrons, 2 in the first shell, 8 in the second shell, 5 in the last shell. The last question asks how many valence electrons phosphorus has. So remember, valence electrons are electrons in the outer shell, right? And this here, this is my outer shell, right? The one on the outside. So 1, 2, 3, 4, 5. So it has 5 valence electrons. Okay, so if you have not already, go ahead and put your question of the day in the bin. There is no stamp today, so don't worry about that, but just complete the question of the day. Ideally, there's actually question of the day papers that I printed out that you guys can use. If you can't find one, write your name on a scrap sheet of paper, do the question on the day on that. Works for me, okay? If you understand how to draw this Bohr diagram, then I am pretty happy as far as question of the day goes. Okay, so that's question of the day. All right, so moving into today's lesson. So you should have 9 and 10 done already. Right, so your homework, you should have had 9 done and then 10 done. I'm going to go over the answers to 10 really quick. So what are valence electrons? So like I said with the question of the day, valence electrons are the electrons in the outer shell, right? So if we look at this here, for example, this is fluorine. How many electrons does this atom have? Well, you can just count the dots, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this would have 9 electrons. How many valence electrons? Well, that's going to be a different story because that is only the electrons in the outer shell, so only the outer circle. 1, 2, 3, 4, 5, 6, 7. So that is 7. This one here, again, same idea. How many electrons? That's every single dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that right? The silicon have 13. Oh, no, 14. It have 14. Let me recount. Silicon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so there's 14 dots, 14 total electrons. Valence electrons, remember outer shell only, right? This outer circle. 1, 2, 3, 4. So 4 valence electrons for silicon. And then when drawing a Bohr diagram, so these, if you look, these are actually already in your packet, these answers. They are right here, but I'll go ahead and go over them. So the first shell holds 2 electrons. Again, if we let's look at silicon, right? See that first shell, that first circle, it only holds 2, right? After you put 2 in it, you have to move on to the next circle. The second shell holds 8. Again, in silicon, we can see there are 8 in the second shell because that one is full. And then the third shell can also hold up to 8. Okay, so you guys should have already been done with page 10, but now I have literally told you the answers to page 10, so there is no excuse for not having this done. Okay, moving on to today's lesson 11 and 12. Okay, so we're going to practice drawing some Bohr diagrams, and I want you guys to kind of follow along and pause the video and try to draw these for yourself. Okay, so go ahead and pause the video right now. Try and draw each of these Bohr diagrams for yourself. Okay, so you guys should have paused it, tried to draw those. If there's a substitute teacher, please go ahead and look at each kid's paper and make sure they've got something, some attempt written down. I know you guys can at least try these. All right, so I will go ahead and show you guys the answers. So let me just do new Microsoft Paint. There we go. Grab this. Let me draw some Bohr diagrams. All right. Okay. So I also want to show you guys where these aren't just random elements that I picked. There is actually an order to them. So if we look at our periodic table, you guys can see where I came up with these. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if you look, it is the second row, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So they're all in the same row, right? And when we draw these Bohr diagrams, you guys will notice that a pattern appears, right? So let's start with lithium. So lithium has 3 electrons total, right? Because of this 3 here. So we're going to do the chemical symbol Li. We draw a circle around it. The first shell holds 2 electrons. So first electron, second electron. The first shell is full, but lithium has 3 electrons, right? So we need 1 more electron. So we're going to draw another circle and put one right there. So this is lithium. The valence electrons, you guys should be able to figure this out. Remember, they are the electrons in the outer shell. So lithium has 1 valence electron. Okay, so beryllium. Again, we're going to start off, our first shell holds 2. And so beryllium, right here, beryllium has 4 electrons. So we've drawn 2 so far. We need 2 more. So its second shell will have 2. So the valence electrons, the electrons in the outer shell is 2, right? There are 2 in the outer shell. Okay, moving on to boron. Boron has 5 electrons. So here's boron. First shell has 2. And then second shell, so there's 5 electrons total, so there should be 3 more to get to 5. So 1, 2, 3. So valence electrons is 1, 2, 3. There are 3 in the outer shell. Okay. Carbon. Carbon symbol is C. I'm going to draw first shell here. Again, there's 2 in the first shell. Carbon has 6, so we should have 6 total. So we've drawn 2 so far, so we need 4 more. And this one should look familiar. We have drawn carbon before, right? So there's carbon. How many valence electrons? Well, 1, 2, 3, 4. So go ahead and look at this number of valence electrons, and you guys should notice a pattern. You guys to go ahead and predict the number of valence electrons that nitrogen is going to have based on this pattern. Go ahead, have your prediction, write it down if that helps you remember it, and we're going to see if you guys are right. So nitrogen has 7 electrons. So first shell holds 2. And second shell. So let's say we've drawn 2, we need to get to 7. 2 plus 5 is 7, so there are 5 in the next shell. 1, 2, 3, 4, 5. All right, so valence electrons. Again, think of that prediction. You should have gotten 5 for nitrogen. And so this pattern, I can go ahead and fill it in now, right? So 1, 2, 3, 4, 5, 6. Oxygen will have 6 valence electrons. Fluorine will have 7 valence electrons. And neon will have 8 valence electrons. And then let me go ahead and draw oxygen, fluorine, and neon quickly. So this valence electron pattern, let me draw that smaller. This pattern is not just for this one row that we looked at, right? It turns out that this pattern holds true for every column on the periodic table. Let me finish drawing these real quick and I will get to that. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 dots here, 8 electrons total. That matches up. And there are 6 dots in the second shell, which goes with the 6 valence electrons. Fluorine has 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then neon. Here's neon. So neon has 10 electrons. So 1, 2, and then the next row, next shell has 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, there you go. So we've got all of these drawn. And again, they follow this pattern for the valence electrons. Okay, let's go back to the notes. So this is your page 11. You should have drawn all that on page 11. So here's the thing about atoms. all atoms want a full outer shell of electrons. So see this outer shell, these valence electrons? These atoms always want a full outer shell. So let's think about how many they want in their outer shell. So hydrogen and helium. Well, hydrogen and helium are small, right? Hydrogen only has 1 electron. Helium has 2 electrons. Hydrogen and helium both want 2 electrons for a full shell because hydrogen and helium are on this first one, right? They're just working on this very first shell that only holds 2 electrons. So in order to get a full outer shell, if you are hydrogen or helium, you want 2 electrons, right? They want 2. And all other atoms want 8 valence electrons, right? Things like oxygen, fluorine, neon, right? The second shell that they're trying to fill up, that has 8. Even if you get into bigger atoms that have the third shell, that shell has 8, right? So hydrogen and helium want 2, everyone else wants 8. We call this the octet rule. Think of octets like octagon or octopus, right? Meaning 8. The octet rule is this: all atoms want 8 valence electrons. Not all atoms, everyone but hydrogen and helium, but that's pretty much all the atoms, right? So it's a fairly universal rule. Okay, so, all right, so next page. And this is probably the hardest thing we're going to learn this unit. So pay attention. If you guys get a little lost or confused, when I come back, I will be able to help you guys out. So just try your best. In order to get the number of valence electrons they want, atoms can they gain electrons, lose electrons, gain or lose electrons, or create and destroy electrons. So if you guys remember, we talked about atoms having charges, right? And how those charges happen because they gained or lost electrons. So the correct answer is C, right? D would not make sense. That would violate the law of conservation of mass, right? So they can gain or lose them, but they have to go somewhere or come from somewhere, right? They cannot just be created out of nowhere or just destroyed forever. Okay, so then we've got a periodic table here. And we're going to label the charge when bonded and the number of valence electrons. So let me just grab this. I'm going to put it in Microsoft Paint. Oh, come on. Let's try that again. Okay, third time's the charm. Come on, computer. There we go. There we go. Okay. Sorry in advance. I know it's a little bit blurry, but the thing here isn't that you have to be able to read everything off of this periodic table. You just kind of have to know where it's at, right? So the number of valence electrons, well, we've essentially already filled that in. Remember when we figured out how many lithium had, how many beryllium had, and so on? Let me pull up that beautiful picture that I have. This one, right? So lithium has 1, beryllium has 2, boron has 3, right? So it turns out, yeah, lithium has 1, but everything in the same column as lithium also has 1, right? So if I look at the periodic table, right here is lithium, and all of these guys have 1 valence electron. Hydrogen, sodium, potassium, rubidium, cesium, francium. All of these guys have 1 valence electron. So if you want to find the number of valence electrons, you can draw the Bohr diagram and then count them. But there is an easier way to do that, and it is to just look off the column. Because once you have this pattern written down, you know the number of valence electrons of everything in this entire column, right? Because for this first column, it's all 1. For the second column, it's all 2, and so on, right? We skip over the stuff in the middle. These guys are called transition metals, and unfortunately, they do not have an easy rule for the number of valence electrons. But then we pick it right back up here with 3, 4, 5, 6, 7, 8, right? So let's go ahead and put that in our notes, right? So number of valence electrons. This first column here, these guys have 1. These guys have 2. They have 3. Oop. 4, 5, 6, 7, 8. Nope. Right. So again, that goes with the columns, right? So these guys all have 1. These guys all have 2. These guys all have 3. These guys all have 4, and so on, right? Okay, so number of valence electrons. Okay, here's the tricky part. And it's not too bad. You can really solve this one of 2 ways. You can logic your way through it, or you can memorize it. So we're going to try logic, and if you get lost in the logic, memorize it, and then you will at least get the answers correct on the test. So the charge when bonded. Remember, atoms can lose or gain electrons. Let's see. I'm actually going to start over here with the ones that have 8 and work our way backwards, just because I think that's a little bit easier to explain logically. So let's look at neon, right? We're going to think about the ones that we've drawn the Bohr diagrams for, because those are going to be a little bit easier, right? So neon right here has 8 valence electrons. Based on the octet rule, its goal is to get to 8 valence electrons. Well, it's already got 8. It's pretty happy. So it's usually not going to bond with anything. And so it's usually just going to have a charge of 0. Right? Pretty simple. Here, charge when bonded. I'll go ahead and put it in red. Okay. So next one, fluorine. Well, fluorine has 1, 2, 3, 4, 5, 6, 7. It's almost at 8. Right? The easiest thing for fluorine to do would be to gain 1 more electron. Right? Well, let me edit this. Nope. We're just going to open it in Paint. Because Microsoft Paint is the best. It really is. I am not an artist, by the way. There we go. All right, so here's fluorine. Fluorine's going to gain an extra electron. There we go. There's our electron, right? Okay, fluorine gains an electron. So fluorine will gain 1 electron. So what would its charge be if it gained 1? What would its charge be if it gained 1? Well, remember, when you gain an electron, you get a negative charge, right? So it will have a charge of -1. Okay, what about oxygen? Well, oxygen has 6, and it needs to get to 8. So it will gain 2, right? 1 here, 1 here. It will gain 2. So if you gain 2, you get 2 more negative electrons. Its charge is -2. Okay. And the same pattern for nitrogen. Nitrogen has 5. It wants to get to 8, so it needs 3 more. They would go here, right? 3 more. So gain 3. So a -3 charge. Okay. Carbon is where things get interesting, because carbon has 4 electrons. So carbon could gain 4, right? We could get 1 here, 1 here, 1 here, 1 here, right? 4 more electrons. Or carbon could lose 4. So if carbon loses 4, right, this one's gone, this one's gone, this one's gone, this one's gone. So if we were to lose all 4, then the outer shell would be entirely empty, right? It would have lost everything in the outer shell. which means that this is no longer the outer shell because it's empty, right? So the next shell in becomes the outer shell. Let me put this in. I've already used red. This guy, right? This right here, this would be our outer shell now because, well, it's the only shell left, but it's the next one in. And this one is full. So carbon would be pretty happy if it lost 4 electrons. Or again, if it gained 4 electrons, right? Either way. Losing 4 and gaining 4, well, those are equally difficult, right? Same number of electrons. So carbon can have a charge of plus 4 minus 4. And I realize that is very hard to fit in the box, so sorry about that. We'll just kind of draw a little arrow. That's carbon, plus or minus 4, right? Okay, so boron. Well, boron's got 3. If we were to gain electrons, it would need 5 more to get to 8. So it could gain 5, that would be an option, or it could lose 3. Well, it's going to be easier for it to lose 3, right? Because that involves less electrons. So what boron would do is it will lose this one, it will lose this one, and it will lose this one. It will lose 3 electrons. So if you lose 3 electrons, we're losing 3 negative electrons, 3 less negative electrons. So we would have a positive charge. So boron's charge will be plus 3. Let's put there. All right, beryllium, again, just like boron, it could lose 2 or gain 6. It is easier to lose 2, so it will lose 2. If you lose 2 electrons, we have 2 less negative electrons. We have a positive charge because we are losing negative electrons. So plus 2. All right, last one is lithium. Lithium just has 1 valence electron. It could either gain 7, right, to fill up the shell, or it could lose its 1 electron. It is easiest for lithium to lose its 1 electron, right? So it will lose its 1 electron. And even erase it to show what it looks like when it's gone, right? There you go. Its 1 electron is gone. Its whole outer shell is gone. And the next shell in becomes its outer shell, right? So then lithium would have now a full outer shell, so it would be happy. So lithium will lose 1, right? Lose 1. Well, if you lose 1 electron, losing a negative electron means you have a positive charge. So it has a charge of plus 1. Okay, so your paper should look like this now. So like I said, there's 2 ways you guys can do it. If that logic makes sense to you, or if you think if you rewatch the video, you can get that logic to make sense, just logic it out, right? Number of valence electrons is easy. Just count to 8. And then logic out your charge when bonding by thinking about the easiest way for that atom to get to 8. If charge when bonding, if you're a little fuzzy on that, go ahead and just memorize these. And when you memorize the charge, make sure you memorize if it's positive or negative, right? Because those are very, very different charges. Plus 1 and minus 1 are completely different charges, right? Okay, so you guys should have that down. So go ahead and work on these on page 12. I will do 1 and 4 with you guys, and you should be able to do the rest on your own. So how many valence electrons does Cl have? Okay, so let's look at our chart here. Chlorine is right here. And there are 2 ways to solve this. You could draw the Bohr diagram, or you could look it up off the chart. Chlorine is in this row, and everything in this row has 7 valence electrons. So chlorine must have 7. So go ahead and look up K and S on your own. And let's do this one. What charge does F usually have when it bonds? So fluorine, fluorine is right here. And everything in this row has a charge of -1. So fluorine has a charge of -1 when it bonds. Chlorine has a charge of -1. Bromine has a charge of -1. All these guys charge of -1 when they bond, right? Everything in this column. So would have a charge of -1. -1 is that lost or gained electrons. So that is gained, right? Gained electrons. Because it's a negative charge, right? You gained more negative electron. Okay, but the charge is -1. And then if you wanted to put some additional information, you could say that it gained 1 electron. Okay. So again, your homework is 9 through 12, right? 9 and 10 should already be done. Get them done if they're not, and then do 9, 10, 11, and 12. And the other thing you guys need to do is your review sheet, which is due Wednesday, October 20th. So let's look at a calendar real quick. Today, I'm recording this at midnight, but yes, you guys will see this video on Tuesday, October 12th. Right? Wednesday is PSAT day. Good luck to you guys, by the way. Then we have fall break. You guys have workday Monday, and then we have class on the 19th. So all this homework is due on the 19th. So you have like an entire week to get this done. And then your review sheet, you even have one more day, right? That is due on the 20th, beginning of class. So 9 through 12 due on October 19th. And Unit 3 review sheet due October 20th. All right. I will see you guys soon. Bye.